Hey guys, in this video we'll learn very important reaction name Knoevenagel reaction. Few points about Knoevenagel reaction. Number one, it is a condensation kind of reaction. Number two, it is a reaction where carbonyl compounds with active methylene group. Okay, so we can say with active methylene. What is active methylene? So when we have CH2 kind of group and both side we have C double bond kind of options, then it is considered as active methylene group. So carbonyl compounds, okay, they are reacting with active methylene compounds, then we get this kind of reaction. So before we proceed further into details of this reaction, we have to understand what could be the flow of this particular reaction. So let's start with carbonyl compounds. We can take, for instance, we take benzaldehyde, okay, and you take anything which is having active methylene group. So maybe we can have something like this with this compound. So it is carrying this CH2 here, and this is a basically C double bond OR and C double bond OR. So they are active methylene groups present here. Now what is the next step? We take bases here. Now base choices is, let's say we take example of base something like pyridine initially. So what does pyridine do? Pyridine is, if you draw the compound, it is a base which will grab the H plus from this place, create an enolate. If you look at this part, so it will become like this, O minus, OR. At this place we have C double bond, OR prime. Okay, if you have problem with this, there's one more option for you. You can simply say, okay, fine, I'm not interested in doing this. We can say we can have CH2 is there. So we can have CH minus at this place. We have CH minus at this place. And we have C double bond OR and double bond OR prime. That's also fine, but this is a better structure. This is a refined structure. So as a chemistry scholar, we should know that this should go to O minus, not in this format, right? This is better one. This is not that great. So anyways, if you understand this, fine. So you can say that this O minus will push it. And now we have a carbon ion kind of thing which is ready to attack where? So it will go and attack here. So it is too far distance. So I'll do one thing. I'll just bring this structure down and I'll draw it like this maybe. And we'll draw PHCHO also here, something like this. Look at this. So it makes more sense. Now you attack. After attack, we will say that the C double bond O will break towards CO minus. So we can expect CO minus. Hydrogen will come at this place. What is connected here? So at this place now we got a connection of double bond OR and double bond OR prime. You can draw like this, double bond OR and double bond OR prime. Later what we can do is we can say that O minus is given, H is given. So do you think like if O minus captures this hydrogen, okay, so this could be becoming what? This could be becoming negative charge at this place also. That option is available for us. So let's write it. It will become a ring, carbon, this is OH, then a carbon, then these things, C double bond OR prime. Now reaction is not yet over because now we have H and OH next to each other, and look at this, H is even more acidic. This particular H I am talking about, this is even more acidic because C double bond O and this C double bond O are pulling members, though there is some cross conjugation with the help of oxygen nearby, but this is sufficiently active hydrogen even than the previous one. So what if we bring something which can take this hydrogen and try to release water out of it? So who can do this job? Definitely a base can do this job. So question is, can we bring this previous base only? So answer is no, because see, previous base was milder base, like pyridine is a milder base. We need something better than that. So maybe we can pick this compound. Look at this one. So the name of this compound is called piperidine, or you can pick some other bases also. So piperidine is even stronger base because there's no conjugation, there's no aromaticity in the structure. So what we can expect, that this piperidine will come and attack this time to this N will go and grab this hydrogen, and in this process, see what will happen. If it grabs the hydrogen, it will create a double bond and water resort. So let me just draw it once again so that it will be very clear to you. This is important reaction, so we should not take chances. C is here, OH is here, On this we got one hydrogen. Okay, anyway, that's fine. And the next position, if you say next position, we have hydrogen. We have C double bond O connections with this carbon position, and with the same carbon position we have connection of C double bond OR prime also. If this is the situation, so let me just do it here now, that will be more comfortable. So we can say this goes, picks up hydrogen, you can create C minus or something, or you can just do it in one step using E2 mechanism. Once you do E2 mechanism, keep in mind that we keep OH orientations proper, and if you do this reaction, what is the end result of this whole process? So this will end up as a ring CH double, once H was already there, so this H is always here, so we get CH double bond CH, C double bond O. Now this is only CH, right, because one H is gone, so CH double bond C, C double bond OR, and C double bond OR prime. This we get as a result. So if you get this thing, so far what we have done, we have taken a carbonyl compound, we are reacting with number one pyridine, and later we reacted the same thing with piperidine. That much we have done, that much we have accomplished. Now after that, what is being done? After that, you can bring something like H3O or H2O first, water. So what will water do? Water will make here at this carbon CH double bond C. At this place you'll get COH and COH. You know that esters are given, so esters can hydrolyze in this case. So with water H plus, we can expect this thing. Okay, so anyway, H plus is available in plenty of amount. We have this member also with us, we have this member also with us, so we have H plus availability. So in this case, we can expect this kind of acid whenever you have two COH group on the same position, and if you heat, so we have done this earlier, on same carbon two OH are not stable, on same carbon two COH are not stable. Okay, revise Ohm's gaps, we have discussed. Malonic acid will give you, if you heat this thing, CO2 will come out, it gives you CH3COH kind of thing, if these are hydrogens. So we know this thing. So based on that, what will be our answer? We can say, if you heat this thing, one of the CO2 will go out, it will form pH, CH double bond CH, C double bond OH. One will go, one will remain. So decarboxylation will happen, and the final answer comes as cinnamic acid. So now cinnamic acid is also achieved in some more reactions like Perkin reaction. If you take benzaldehyde and take acetic anhydride and sodium acetate, you can again get the same cinnamic acid. You can also do one thing, you can take cinnamaldehyde, you try to oxidize it, you can get cinnamic acid. So we have multiple reactions. I hope Knoevenagel reaction is very clear. It's a reaction of active methylene, okay, on this kind of aldehydes and in presence of bases, and then later water H plus is given. So it's a long reaction, very important reaction. I hope you can do this and you can solve questions based on this. Thank you very much.